want to talk a little bit about big data and analytics. Very introductory. Um, I love Dilbert, and basically it says I need some data from an unreachable guy named Ed. What should I do? Well, just make up a bunch of data like everyone else does. Everyone else does that. Are you doubting my data? I know people that have done things like that. We used to say we had a mountain of data, and I like to show this mountain because this is the peak of Mount Ararat, the mountain of Armenia, where Noah's Ark landed, theoretically. So, mountain of data. Now we have a mountain range of data. We've got more data than we can know what to do with. And the storage is growing at a mind-boggling growth. And if you were to read this article, you get a feel for that. And there's a couple types of data. There's structured data and unstructured data. If I have the name and address and major and transcript of every North Park student, that would be structured data. It could be keyed in and sorted by student number, and then there would be a student name associated with it. And in that file of that large data structure, it would have all the information you need to know, and it's very structured so that the address is in the same place and everything, the phone number, home phone number, cell phone, work phone if needed, email address, personal email, North Park email, all the classes you've taken, all the grades that basically make up your transcript, probably your history of if you're an employee, your pay history and compensation history, and if you're a student, your tuition payment history, and and all that would be in there. Unstructured data is messier, harder to deal with. It has to do with basically you're looking at data that doesn't have that keyed feature and ability to sort on it in the same way, and it has to do with feedback. Normally if you're talking about a survey and you have all the answers to the survey, rate this question from 1 to 5, rate this question from 1 to 5. That's pretty structured. You can sort on that in any way you want. But then if you go to this part of the survey that's the verbatims, well, what do you think about this and what do you think about that? And some people type a few words, some people type a few paragraphs. That kind of verbal feedback data is kind of what's unstructured. And organizing that and including that in your data and any analysis you do with it is much harder. So structured data, highly organized, made up of tables and rows and columns. And examples are Excel spreadsheets and relational databases. Most of the data that you use to run a business. Unstructured data is emails, instant messaging, text messages, all that verbal data. Word documents, PDFs, all the pictures that are in my phone would be my unstructured data. Even though I can structure it by date, but I can't structure it by, pictures of my granddaughter versus pictures of my grandsons. PowerPoints, SlideShare presentations, your audio files, music, voicemails, all that kind of stuff is all unstructured. And companies have tons of that, right? Video files, movies, personal videos, YouTube uploads, images of pictures, illustrations, and memes. So that's the stuff. So there's like 13 different types of data, and you could look at this article to see what they're talking about. I like the structure to those two. So there's an explosion of data as well. Between the dawn of civilization in 2003, we only had 5 exabytes of data. Now we're creating that amount every 2 days. What? That's crazy. By 2020, this year, that figure is predicted to sit at 53 zettabytes, 53 trillion gigabytes, an increase of 50 times. This is from Hal Varian, who's an economist at Google. IBM found that humans now create 2.5 quintillion bytes of data daily. That's equivalent of about 500 million HD movie downloads daily. Well, how many pictures do we take? How many videos do we take? Um, what do we do with all that data? We're texting, we're sending pictures, it's just crazy. The ability of technology to keep us interconnected in that way has just blossomed. Um, if I recall to the days of film cameras, you were judicious in the number of pictures you took because it cost money to, one, buy the film and two, develop it. Here, it doesn't matter. You don't like the picture, you throw it out. Even if you don't like it, you don't throw it out. So we accumulate all this data. And here's all the prefixes that we use. We started off with a byte of data and a kilobyte of data, a megabyte of data. I remember my first hard drive that was 10 megabytes. I thought, oh, we'll never fill that up. And then we went to gigabytes. And now I have a backup. My backup hard drive is 2 terabytes right now. And I haven't used any of these terms. I just used them in this presentation. Peta, xn, zeta, and yoda. Interesting. So we have all those prefixes. We have the structured data. We have unstructured data like we talked about. Structured data is very organized, rows, columns. We could sort on either the row or the column. Usually we sort on columns because the rows are the different data entries. The unstructured data, it's like if I have all my pictures and say, oh, find me pictures of Professor Vollmer. I can't really sort on that unless I've tagged all the pictures and I've made it unstructured structured. But if I show a picture of Brian Vollmer and maybe I have some search mechanism that can say, here's a picture of him, go find all the pictures that I have of him, it could do that. So we have this explosion of data. And we have noticed all this growth has happened in unstructured data. Mostly, I think it's people with their cell phones taking pictures, sending texts, taking movies, and all that stuff. The growth of structured data seems to be more metered and more controllable, even though it's still kind of an exponential growth. So growth of unstructured versus structured data over the past decade shows unstructured data accounts for more than 90% of all data. And we're not really using that right now. Another chart shows the storage supply and demand of growth over the past 2 decades. So where do you store all this data? Storage has gotten cheaper, but it still costs. So my view of this is you have data. You can't make decisions on data. You have to transform the data into some kind of information. And then from the information, you can make decisions and hopefully better decisions. So you want to mine your data. They use the word because we have these mountain ranges of data, like you're going to mine copper or iron ore out of the mountains. You're going to mine the data that you need out of the mountain of data, the mountain range of data that you have. Then you might look at multiple sources. You might even have data from multiple mountain ranges. You have to refine the data, which is basically clean and organize it. Then you analyze it. This part here could take 80% of the whole analytical part. So it could take a while. The term big data by itself, which used to encompass all this, is becoming a little bit passé, because as the field gets more refined, the titles get more refined. We have data analysis, we have data science, we have data engineering. So we have a data analyst, we have a data scientist, and we have a data engineer. They all have different roles. It used to have big data and analysis, it was one topic, and you had a guy a data jockey, a data analyst that went through it all. The open source tools for doing this have gotten very, very popular. In other words, because what makes big is it doesn't fit into an Excel spreadsheet. If it doesn't fit into an Excel spreadsheet, it somehow tends to be too big for the known statistical packages. So an open source statistical package like R doesn't care how big the data is. It'll figure it out. It'll analyze it. And then maybe it's too statistical and you need more tools to refine and manipulate and massage the data before you analyze it. So there's been a growth of a language called Python. They both kind of do the same thing. Python is more used by non-statisticians, and R is more used by purely statistical kinds of folks. And there's a big overlap, obviously, between the two. And AI is playing a larger role in its data analysis. So here's some 15 astonishing facts about data analytics. And this data is a couple years old, but you get the impression. So less than 0.5% of all the data we create is ever analyzed. I forgot something like how many terabytes of data, if a plane flies from New York to Chicago, you have a couple terabytes of data generated by each engine. Temperature, fuel flow, this, that, the other thing. I'm not an airplane engine, a jet engine engineer, so I don't know what kind of data they need to keep track of maintenance, this, that, the other thing, but I'm sure temperature, airflow, fuel flow, blah, blah, blah. So, but anyway, they generate a couple terabytes of data on engine performance through the entire profile of the flight. And if they accumulate for like engines all this data on all flights, and over time, you would imagine the amount of data that you have could be overwhelming. And what kind of questions you want to answer, you have to refine that data and get what you want out of it. 73% of the organizations have already invested or will invest in big data by the end of 2016. 10% increase in data accessibility will result in more than 65 million additional net income from the kind of analysis they do. Google uses about 1,000 computers to answer a single search query. By 2020, there will be more than 50 billion smart connected devices in the world collecting, analyzing, and sharing data. We had last year, that was 2015, I'm guessing, 1 trillion photos were taken and billions of them will be shared online. In 2017, nearly 80% of the photos will be taken on smartphones and most will become searchable data. 40,000 search inquiries every second on Google alone. 1.2 trillion searches per year. By 2020, this year, about 1.7 megabytes of all new information will be created every second for every human on the planet. 1 billion pieces of content are shared via Facebook's Open Graph every day. Bad data costs U.S. businesses about $600 billion. Big data will drive an estimated $232 billion in spending in 2016. 70% of the data created by individuals, is created by individuals, but enterprises are responsible for storing and managing 80% of that. A stack of CD-ROMs equal to the current global digital storage capacity would tower 80,000 kilometers beyond the moon. There are nearly as many pieces of digital information as there are stars in the universe. It's, like I said, crazy. Here are some predictions for 2018, which was come and gone. 25% of enterprises will supplement a point-and-click analytics with conversational interfaces. I don't know if we have that. 20% of the enterprise will deploy AI to make decisions and provide real-time instructions. We're getting closer to that. I don't know. AI has always been a promise. It's been a promise since 1985. I think we're closer to that promise now, but I still think we're over-promising on what we're doing with it. AI will erase the boundaries between structured and unstructured data. I could see where that would happen. If I want pictures of a certain person attached to a file, I could go through all the pictures that are presumably stored on my in Apple if I could have access to it and get the pictures, every picture that's ever been taken of that person on any Apple device that uses cloud storage. That's nuts. I don't know why I'd want to do that. 33% of enterprises will take their data lakes off life support. 50% of enterprises will adopt a cloud-first strategy for big data analytics. 66% of enterprises will deploy insight centers of excellence as a remedy for organizational misalignments. The title of Chief Data Officer is something that's forthcoming. Data engineer will become the new hot job title. And the insights as a service market will double as insight subscriptions gain traction. Academia will be the new insights partner for enterprises. So what's a data lake? It's instead of a database, you take your on-premise data movement, you take your real-time data movement, you have machine learning and analytics and pile all of that into one thing. It's not a database anymore, it's a data lake, it's murky, it's got stuff all over the place. And how do you sift through that to find what you're looking for? Why do you need a data lake? Organizations that successfully generate business value from their data will outperform their peers. So a survey saw organizations who implemented a data lake outperforming similar companies by 9% in organic revenue. The leaders were able to do new types of analytics like machine learning over news sources like log files, data from click streams, social media. You know, it's like Big Brother is watching you. All your data is part of a large lake. You know, when I react to this, I wonder how come then that if I go on Amazon and search for an electric mandolin, and maybe a few other sites and search for it. Of course, I expect to see ads for electric mandolins on Facebook and other social media that I go because it knows I looked for it. How come it doesn't know that I actually bought one and stop advertising the darn thing to me? But yet it does, so I don't know about AI there. What do we do with all this data? Really, there's so much of it. What do we do with it? Well, there's some ideas. We call it analytic, and the future will really tell where this goes. So the building blocks of business analytics. You have business intelligence. What has happened? Strategic performance management. Okay, so what happened? Let's look at it, and let's find out what other people are doing, and let's see what happened. Explanatory data management or intelligence. Why did it happen? Defining, correlating, finding causation between different factors, and getting those performance drivers. So this is descriptive. Now you want to say inferential, predicting what's going to kind of happen. Because realize that when you forecast a prediction sometimes, predictive analytics sometimes is just forecasting. Forecasting is predicting the future. How good are we at that actually? So expected performance based on alternative circumstances or approaches. The more we learn, the more we can help predict that. Will we ever become perfect at it? I doubt it. Optimization, what is the best path? So you discover a course of action that will create the best outcomes based on a balance of strategic and functional constraints. So it gets really analytic as we go up this, here's kind of like what happened. What happened? What do we learn from that? Okay, let's not do that again, or the result was good, let's keep doing that. And you work your way up. So it's if you go here, it's increasing insight and foresight, and here it's increasing business value on the y-axis. So here's some other things you can look at. And that's where this presentation comes from. Data gathering solutions are now becoming the most cost-effective and available, even to small and medium businesses with limited budgets. I still think some of the mom and pop companies are unaware of this and need to become aware of this. So with this, digital marketers are moving towards generating meaningful intelligence from this data and using them to improve customer engagement and boost their businesses. At the forefront is predictive analytics. Once only available to high-end users, it's not becoming available. One, because we're generating lots of people with master's degrees in this stuff. And as they're all looking for jobs, they're becoming probably more affordable. And companies will want to use them. A recent survey of 308 marketing directors and CMOs, chief marketing officers, conducted by Forbes, suggests that predictive marketing can help organizations get better insight on trends and preferences of their targeted customers, resulting in better and more targeted lead generation results. Definition. In the most basic sense, predictive analytics is the use of statistical data and advanced analytics to predict future events. You're still predicting the future, which is, if we're not that good at that, no matter how much data we have. It is not the new concept, but the ability to predict what your targeted customers would want, need, or buy in the future makes predictive analytics a holy grail of digital marketing, giving users an incredible edge over marketeers who do not do it. So I think you can do better if you can reduce your error. Great. So phases: collection, reporting, analysis, deployment. I think we talked about that. And you can read this in more detail. I don't want to read every slide. So there's my first example of not reading that slide for you. The benefits. In the most general sense, predictive analytics can help businesses attract new customers as well as retain or even grow their most profitable existing customers. Here's the benefits of what makes that happen. It helps predict or estimate search and purchase behavior of targeted customers. Knowing customer behavior helps optimize marketing campaigns, helps businesses analyze and manage pricing trends, and I think it also helps in your product offering, certainly. Knowing customer behaviors helps optimize campaigns, promote new products, helps businesses analyze pricing trends. We talked about that. A better understanding of customer trends and demands enables optimum supply chain management. That is for sure. Provides better business intelligence, allowing a business to forecast and plan for growth. And again, from Forbes, it says, will help deliver a positive return on investment by as much as 25%, according to 86% of the executives using these technologies. So as much as 25%, according to 86% of the executives. We'll figure that out. Understanding customer behavior and patterns will make it easier to detect and manage fraud. Hopefully we get better at that. So correcting digital marketing mistakes. You focus on getting more customers instead of solving existing and perceived customer problems. You want to make abrupt decisions based you want to stop making abrupt decisions based on untested data reports. You know, that shooting from the hip kind of thing. Perform lead generation from the wrong basis. Conduct lead generation without sufficient data points. Starting lead generation through untested and unpredictable marketing reports. And then search engine optimization and e-commerce. There's obviously things that you can do there. Social media marketing it will help you in. And trends in predictive analytics. This probably we can spend a little time here. Popular analytic techniques in use today like clustering, decision trees, and regression will be beefed up using time series data analysis, machine learning, and ensemble modeling. Open source solutions like R and Python will be utilized more extensively in improving predictive analytics at the enterprise level. Instead of processing and analyzing data on disk, in-memory analytics will enable processing of data in the random access memory, allowing better and more effective analysis of larger data sets. Organizations will make use of business intelligence and predictive analysis services from the cloud, allowing for real-time analysis from multiple sources. So, business will be turning more and more to big data. Many are investing heavily in these technologies, and with the recent advances, smaller businesses and nonprofits should be able to profit to some degree from that. So what's the difference between a data scientist, a data analyst, and a data engineer? You can look up in this reading right here. So if you have any questions, let me know. This is just an overview of big data and analytics. It's just a little bit more than the textbook gave without tying it to social media. So thank you very much for your attention, and we'll